Hi Year 11, let's start talking about something called activity series. So, we notice that these displacement reactions sometimes occur between metals where one metal likes electrons more than the other. And so one ion in solution can take electrons from a solid metal and displace it. Okay? So if we take all our knowledge from that and we rank these metals in order, what we get is something called an activity series. Okay, and here's a representation of it that I've got here, where I've got the most unreactive down the bottom and the most reactive at the top. Okay, you should notice the order of the pattern is roughly from what we were seeing earlier when we were talking about reacting with oxygen and water and metals. Okay, sorry, oxygen, water, and dilute acid. So we call this ranking the activity series. The more unreactive it is, the more likely it is to take or hold on to electrons. Okay? Take or hold on to electrons. The more reactive it is, the more likely it is to give up electrons. It likes to give them away. So if you think about lithium and potassium, we know they're group 1 metals. We know that they're very unstable. We know they love to give up their electrons to have their full outer shell. Okay, that's why they're up there. They're more likely to give their electrons away. The more unreactive ones are likely to take or hold on to those electrons. Okay, so this ranking we call an activity series, or sometimes you'll refer to it as the metal activity series. Okay, let's use our knowledge here in this past paper question. A student performed 3 tests to investigate the relative activity of metals. In each case, a metal strip was placed in a solution containing ions of a different metal. The results are shown here in diagrams. Okay, so in this one, they place metal X in a solution of Y, and Y has deposited it on it, and X has gone into solution. So we had a displacement reaction. And here in the second one, we also had a displacement reaction between Z and Y. But X and Z, no reaction as well, okay? So what order, okay? So we know that Y will takes electrons from X, okay? Because X went into solution here, okay? And we know that Y also took electrons from Z, metal Z, from the second one there. Number them up there. But here, Z didn't take electrons from X. Okay. So, the most reactive, or the least, sorry, let's do it least reactive. The least reactive is the one that holds on to electrons more. So Y took electrons from X and Y took electrons from Z. So Y is the one that likes its electrons more, okay? So it's the least reactive, okay? It likes the electrons the most, okay? Now we just got to consider X and Z, okay? Long pause. Okay, Y took electrons from Z, okay? So Z's somewhere up here, but we need Z relative from X, okay? So Y took it from X, and Z took it for, okay, and then we have Z. Z didn't take its electrons from X, okay? So that means that X would take its electrons from Z the other way around. So I have got the right order, okay? Z and X. So Z can't take electrons from X, and X can't take electrons from Y, but Y can take them from X. So it should be this one here, YXZ, so that should be B. I'm pretty sure I've got it around the right way. Yep. That's the way that we... I'm pretty sure. That's terrible, isn't it? Okay, a piece of zinc is placed in a nickel 2 nitrate solution. From our activity series here, would you expect a displacement reaction to occur and why? Okay, so I always like to draw a little beaker here. It helps me visualize. Okay, we've got zinc and we've got nickel 2 in solution. Are we going to get a reaction? So let's find zinc. Zinc is here. And let's find nickel. Nickel is here. So nickel's more wrong. I was going to say more unreactive. Is the most unreactive of it. So it's the one that likes electrons the most. Okay. It likes electrons more than zinc. Zinc has the electrons, nickel doesn't. So what's going to happen is we are going to get a displacement reaction. We are going to get nickel taking up 2 electrons, going to nickel solid, and we are going to get zinc solid, going to zinc 2 plus giving up 2 electrons, okay? Because of that ranking in the activity series. All right, here we go. Oh, look what I did here. Here, what I deliberately did is the opposite. Now we have a piece of nickel. And we have zinc in solution. Okay. Zinc is here. Nickel is here. Nickel is more towards this side, the unreactive side. So nickel likes its electrons more than zinc. Nickel's already got its full shell. It's not going to give up any electrons to zinc. So what's going to happen? Nothing. No reaction. So these reactions, these displacement reactions, are only going to go in one direction. They're not going to go in the other. All right, example 3. Why did I put 3 there? 3. Charlie wanted to observe a displacement reaction between zinc and tin. Explain how this would be possible. Which reactants are ions and which are going to be solid using chemical equations. Okay, zinc and tin, let's find them here. Tin is down here. And zinc is here. Okay, tin is more unreactive, so tin likes electrons more. So if we want a reaction, what we're going to have is tin in solution. It's going to steal the electrons. So we need tin in solution, and we need solid zinc. Okay? Because tin is more unreactive, tin is going to steal electrons away. So zinc is going to go into solution, and tin is going to coat that one. Okay, chemical equations. So we've got tin 2 plus aqueous, and it's going to need 2 electrons to go into solid tin. And we're going to have zinc solid going to zinc 2 plus, and it must produce 2 electrons. So we've got something taking up 2 electrons, the tin, and the zinc donating 2 electrons. So that's all good. We can just add them together. Plus your 2 electrons, plus the zinc solid, going to tin solid, plus zinc 2 plus, aqueous, I did put the state there, terrible, plus 2 electrons, cancel out 2 electrons, and we're left with tin 2 plus zinc, going to zinc 2 plus tin solid. Alright, so that's the only way a reaction would happen. It wouldn't happen other way, where you had solid tin and then zinc in solution, you get no reaction. Alright, so we're going to do a practical making activity series. We're going to see these type of displacement reactions in practice and make our little own. I think we should keep going and relate it to the periodic table. Yeah, let's keep going and finish up the activity series. Okay, So the syllabus is asking us to look at the patterns in metal activity on the periodic table, explain how they correlate with ionization energy, atomic radius, and electronegativity. So here I've got periodic table and I've got our activity series. Okay. So have a look what patterns you can see. You can pause it if you want, but I'm going on. Okay. You can see that the group 1 metals are the most reactive, followed by the group 2. And then group 3 and some transition metals, and then group 14. Okay. Other trend that you can notice are metals in group 1 and 2, the reactivity increases from top to bottom. Okay. So very roughly, reactivity decreases from left to right. So unreactive, and from top to bottom. Awfully similar to something we've seen, the pattern of ionization energy. Okay, so the energy needed to remove one electron is closely related to, if not a function of, activity. Okay. All right. The reactivity of a metal is strongly related to how easily it can lose electrons, okay, or its ionization energy. So it's a strong indicator of its reactivity. It's not the complete story though, okay? Atomic radius also comes into play. As the atomic radius increases, the outer shell electrons are further distance away from that positive nucleus, attracting them in. The energy to remove them from the atom is less, and the reactivity is higher for larger radiuses. Okay? Another way to think about it all. Reactivity of metals is a measure of how easily a metal will give up its valence shell electrons. That's general. Think about electronegativity. Electronegativity, back from the other module, is a measure of how much an atom will gain electrons to its valence shell. So there's an inverse correlation between electronegativity and activity and reactivity as well. Okay. All right. You can do worksheet 3.07, and we'll leave this video there, and we'll pick up with these big words. Okay. See you in the next video.